Okay, these are your answers from last Friday's assignment on AP Classroom. I don't have my pen on me, so that's going to be kind of ugly writing, but let's see what we can do. So we have what is the limit as h approaches 0 of cosine of 3 pi over 2 plus h minus etc. And I wanted to make sure that you knew that it was this form, that this question looks like a limit question that we could solve with two ways. One, we could solve using L'Hopital's rule. Or two, we could use using a derivative. So, which is kind of like L'Hopital's rule, but sort of not. So I'll do L'Hopital's rule first. To do L'Hopital's rule, plug in 0 for both, for h. So if we plug in 0 for h, we get cosine of 3 pi over 2 minus cosine of 3 pi over 2, which is 0 over 0. So that's a L'Hopital's rule. And when we take the derivative, we pretend that h is x. So we can get the limit as h approaches 0 of the derivative of cosine of 3 pi over 2 is going to be negative sine of 3 pi over 2 plus h. And then the derivative of this part of minus cosine of 3 pi over 2, that's just 0. And then we add the derivative of h here, which is basically x, which is 1. And now when we reevaluate, we end up getting out negative sine of 3 pi over 2 over 1. And sine of 3 pi over 2 is negative 1, with a negative in front is a positive 1. So I'd say my answer is A. I say that my answer is A. Alright, let's do it with the derivative. So I'll do this work in purple. The way you do it in derivative is you find the function. So we're saying what function could we possibly be using? And the function that we're using is cosine of x. Okay, and since we know that we are looking at a derivative here, we take the derivative. F prime of x is negative sine of x. And finally, what value am I trying to evaluate? Well, it looks like I'm plugging in 3 pi over 2. That's the x value that I'm plugging in. So I need f prime of 3 pi over 2, which is negative sine of 3 pi over 2. And that's the same exact thing that we had here, which is 1. So that's how you can solve the limit two different ways. Second, an equation of the line tangent to the graph of f of x. Okay? Tangent means derivative. So let's do a derivative first. F prime of x is equal to, now before I do this, I notice that I have a product. I have a product rule, but then I also have a chain rule. And the chain rule is because I have a function inside a function. So let's set a product rule first with a first, second, plus second, first. We'll do a first times second prime plus second times first prime. X will be f, and this one will be s. So we have x and a 1. And I'm going to hold off on the s prime, but this one's going to be 1 minus 2x cubed. Okay? Now, for the second prime, I'm going to do some side work. So the ddx of 1 minus 2x cubed is going to be a power rule, so the 3 is going to come down in front. Drops by 1, so now it's squared, but now it's times the derivative of the inside, which is negative 2. So what I'm going to get all together here is I'm going to get x times a negative 6, 3 times negative 2, so negative 6, 1 minus 2x squared. And then we have a plus sign in the middle there. Now, a lot of students like to simplify that or factor it or do something fancy, but all I'm going to tell you is get to the point. And the point of the problem is to find the equation of the line tangent, which means that I actually need the slope, right? So if I want to write an equation of the line tangent, I need a slope, which is why I did the derivative here. Okay, so let's get the slope at the x value. So we need f prime of 1. And f prime of 1 is going to be 1 times negative 6 times 1 minus 2 times 1, which is just 1 minus 2 squared, plus 1 minus 2 times 1, which is 1 minus 2 cubed, and then times that extra 1. Okay, if I clean this up, I get negative 6. 1 minus 2 is negative 1 squared is 1. So just negative 6 for that first part. 1 minus 2 cubed is a negative 1, so 6, negative 6 plus negative 1, that's going to be a negative 7. Okay. So to write the equation, I'm going to need to write in a point slope form. I get y is equal to negative 7x minus 1 minus 1. That's point slope form using the point 1, negative 1. And if you're not sure, the negative 1 is, this y value of negative 1 is right here instead of on the other side. This one is right there. Okay, now let's clean this up. So we get negative 7. And then if we distribute this, because this is slope-intercept form, the answer, not point slope form. So negative 7x plus 7 minus 1, which is negative 7x plus 6. And I believe that that was answer A. It is. I could have clearly stopped at when I got the slope because it looks like each one of these answers is different based on the slope. There's your answer. Let's go to the next one. Question 3. So here we're looking for a derivative. We need a quotient rule because we have a quotient of two functions. We have a fraction containing two functions. The formula, the rule for quotient rule is low d high minus high derivative of the low function, all divided by a low squared. Okay, the low function is x times the derivative of the high function. The derivative of the high function is 1 over x. And then we have a minus. The high function is going to be ln of x. I'll do ln of x times the derivative of the low function, which is going to be times 1. I'll put this in green just so that way it's not so confusing. Now it's really confusing. And then it is divided by low squared, which is going to be x squared. All right, let's clean this up. X times x, that's just going to be a 1. So that's just going to be a 1 overall. So it looks like we get 1 minus ln of x divided by x squared. Oh, that's easy peasy. That's d. Number 4. Oh boy, that's a lot of information. It looks like it says, though, that h of x is equal to a composite function. So when h of x is equal to f of g of x, and they want me to do h prime of 1, and that means I need a derivative first of h of x. Forget the 1. I just need h prime of x first. So h prime of x, this is going to be a chain rule 1, and the chain rule works with the derivative of the outside function first, keep the inside, just like that m&m, and then times the derivative of the inside. Okay, so now you're going to go and plug in h prime of 1, because again, the 1 is what we need. So now we have h prime of 1 is equal to f prime of g of 1 times g prime of 1. And now let's go up to this information here. G of 1 is 2. So we have this is equal to f prime of 2. And then times, let's see, g prime of 1 is, g prime of 1 is negative 3. So times negative 3. And now f prime of 2 is going to be negative 4. So we have equals negative 4 times negative 3. You got a positive 12 there. Question 5, average rate of change. So the average rate of change is going to be always a formula of f of b minus f of a over b minus a. And as I know Schwartz refers to it, it's old school slope. Old school slope. Don't say slop, it's slope. All right, so let's go on. I always like to set up this part first, just so the people who are grading my test know what I'm talking about. I do f of 3 minus f of 0 over 3 minus 0. That's number 1, just so they know that I know what average rate of change is. Second, I do some side work here. Let's just get f of 3. F of 3 is going to be 3 to the 4th minus 5 times 3. I'm going to guess that's 81 minus 15, which is going to be 66. So I end up getting out, it's going to do 66 here, so 66 minus, now f of 0, we'll just get you 0 here. So this part is 0, so minus 0 over 3. Over 3, which is going to be equal to 66 over 3. 66 over 3 is approximately 20, oh, not approximately, it's equal to 22. There. All right, guys, that's the answers for the last multiple choice. If I had any mistakes, please let me know. Thank you for watching.